This is problem 37 of chapter 8 of Giancoli 6th edition. So we have a rotor rotating at a certain initial frequency. So this initial frequency is given to us. It's actually given in RPM, so a good idea is to change the units to revolutions per second. It's shut off and is eventually brought uniformly to rest by a frictional torque. So we know that the final frequency will be 0. And this is done uniformly, and we know what is the frictional torque. The value of this frictional torque is also given to us. They give us the mass of this rotor, and they say that this is approximated by a solid cylinder of a certain radius. So by that, they are actually also giving us the moment of inertia, which is 1/2 of mr squared for this cylinder. They want to know through how many revolutions will the rotor turn before coming to rest. So the question is, how many revolutions? To get this number, we need to find the angle. If I have the angle, I can know how many revolutions. So I'm going to look for an equation that involves the angle. I have no information about time, so I'm going to avoid an equation with time. And so I'm going to start with this one, where we have the final angular velocity is equal to square is equal to the initial plus 2 alpha delta theta. So I see the angle showing up there. That is good. Let's see about what we can say about the other terms. Well, the final angular velocity, we know it's 0 because the final frequency is 0. The initial one we can obtain. This is just 2 pi multiplied by that initial frequency. And then comes the question, can we have this acceleration? The answer is yes. And let's make an assumption here. Let's assume that our object is moving counterclockwise, so this initial angular velocity is positive. From that, we know that the acceleration and the torque, the frictional torque, will be negative against. Okay, will be against that motion, so will be negative. Okay, with this information, I'm going to come to try to find what is this acceleration. I can find the acceleration using the torque. I know that the torque is moment of inertia multiplied by the angular acceleration. We have the moment of inertia, so we can find the acceleration. So from all that, we'll be able to find that angle. Okay, so the equation that we are going to use is 0. What we get from this value here, I'm going to use a minus sign from what we assumed for the acceleration to the magnitude of that value of the acceleration and then the angle. Once we have the angle, the only thing that we need to do to find the number of revolutions is just divide this angle by 2 pi. So this is part A of the problem. Part B is much easier. They just want to know how long will it take. Well, if we have the angular acceleration, if we have the final and the initial angular velocity, we can then find the time. And that's all we need to do.